Alright, today we're looking at Pythagorean theorem and SohCahToa, so the basics of trig, right triangle trig. So if you remember, the Pythagorean theorem is a squared plus b squared equals c squared, and that is when c is the hypotenuse, so that is the longest side on the triangle, and also the side that's always directly opposite of the right angle. So SohCahToa is really just a mnemonic device to help you remember that the sine of an angle is the side opposite divided by the side that's the hypotenuse. So that's the SOH, is opposite and hypotenuse. Cosine of an angle is the adjacent side divided by the hypotenuse. And the tangent, the TOA, is the opposite divided by the adjacent. This little symbol on here that you're seeing, that is the Greek letter theta, and that is just a variable. It's just used for an unknown angle. So that's kind of what we use when we get into more advanced math. Alright, so the first examples are just using the Pythagorean theorem, which you most likely have done before, but maybe not. So a squared plus b squared equals c squared. It does not matter which side is a and b. The one that matters is the c. The c has to be the hypotenuse. So in this case, the c value is the x. So I'm going to use 4 for a and 7 for b, and the x is going to be my c. Okay, so 4 squared plus 7 squared is 65. And then to undo the squared, you would take the square root of both sides. So the square root of 65 is going to be approximately 8.06. So exact answer would be the square root of 65. This would be the estimated answer, the 8.06 on here. Okay, so for part B, the difference here is that we have now we were given the hypotenuse, so the 12 is going to be the hypotenuse on here. So that is going to be the c value. So it doesn't matter if you make x a or b. So if I say x squared plus 8 squared is equal to 12 squared, and then I simplify those. Well, I said I was going to simplify and then I didn't. So let me erase this. That would be 64. So subtract 64 from both sides, and you get 80. And then the square root of 80. If we're going to get an approximation, that is about 8.94. Okay, so that's a quick review of Pythagorean theorem. Example 2, we're just identifying which side is the opposite, which is the adjacent, and which is the hypotenuse. So what I like to tell people is pretend that you are a little person and you are standing at the angle that they have indicated here. So here's where the theta is. So here's my little person. That's where I'm standing. The hypotenuse is never going to change. The hypotenuse is always the hypotenuse. So in this case, here's my hypotenuse. Now I look at which side is opposite. So if you were that little person and you had to walk all the way across the triangle to get to one of the sides, that's the side that's opposite. So on here, I would have to walk across the triangle to get over here. That one would be the opposite, which means the other one, which is like right next door, that's the adjacent. Okay, so here we're just identifying which one's opposite, which one's adjacent, which one's the hypotenuse. Okay, so same thing here. I'm going to take my little guy and we're going to move him over here. Okay, now which side is the hypotenuse? That one never changes, so identify that one first. This is going to be the hypotenuse out here. Now the one that is all the way across the triangle, that's the opposite. It's opposite of the little person. So this one is the adjacent. Okay. Alright, so for the next set of problems here, now we are using the triangle, we're identifying each of these, the sine, cosine, and tangent, using this triangle to the right. So, to start, we're going to start using angle L. So if I'm starting with angle L, that means this is where I'm standing. Okay, this is the angle that we're starting from. So if I want to use sine, I'm going to rewrite this up here so we remember. So from this vantage point, the hypotenuse, identify that one first, that's going to be the 37. The one that is opposite of the little person is over here, that's the 12, which means the 35 is the adjacent. So now, sine means I look at this SO up here, SOH means sine is opposite over hypotenuse. So we have opposite was 12, and the hypotenuse is 37. Cosine then, the CAH, C-A-H, means cosine is adjacent over hypotenuse. So if I look on here, the adjacent was the 35, hypotenuse is the 37. And then tangent, T-O-A, TOA, means tangent is opposite over adjacent. So I would have 12 over 35. Okay, now we're going to go from angle N. So what that means is my little guy is going to move over to here. He's at angle N now. And now, which one the opposite is and which one the adjacent is will now change. Since the little guy moved, now this is the opposite and this one's the adjacent. So now, sine, opposite over hypotenuse, is 35 over 37. Cosine, adjacent over hypotenuse, is going to be the 12 over the 37. And the tangent, opposite over adjacent, is going to be 35 over 12. Okay, notice on here that the cosine of L is the same thing as the sine of N, and vice versa. The sine of L is the same thing as the cosine of N. That's just kind of one of the properties that goes with those.